Greetings and welcome to this edition of Content Evolution New World. Kevin Clark here, East Coast, Mike McGuire, West Coast. Mike, good morning.
Good day. How is it? How are you doing, Kevin? Greetings,
I'm doing
everybody
good
else?
here in Chapel Hill, and just down the street on camera is Richard Boyd, our guest today, talking about data provenance, data readiness, data sovereignty and transparency. It's going to be a good session because this is where you're going to get to dive in and learn about why it's important to organize and hold on to your data in a world that's increasingly digital. Richard, how are you this morning?
I am great and admiring all the problems as usual. So great to see the
Yeah,
Content Evolution group here today.
yeah. I mean, this topic is actually old hat for you. You've been talking about this for a long time. So we have a great subject matter expert. Unpack the top of why is getting your data ready to be digital, whether it's AI or otherwise, why that's important, right? From your perspective.
Yeah, I mean, again, to most, as we had a sidebar yesterday with David Bray and a few folks, and I said,
Mhm.
a lot of this will appear retrospectively obvious, as most big ideas do to most of you or any practitioners in this space. But yeah, I mean, it's about getting, people to recognize that we are in the midst of, not the beginning, but the midst of the throes of the information age, and getting your data organized and in order and doing an inventory of it is step one. But
Mhm.
it's still to all of us who are actually doing these sorts of applications and we've been doing them, as you know, Kevin, in financial institutions, in academic institutions, in government, in defense, a lot of different environments. And I have yet, and I think by our count, we're around 70. We were just counting yesterday, 70 deployments of machine learning systems and knowledge graphs in various organizations. And we have yet to find anybody when we start that first inventory of the four V's of your data, the volume, variety, velocity, and volume, variety, veracity, and there's a fourth one. What's the fourth one? I always forget the fourth one. Um,
Volatility.
uh, Veracity, velocity, volume, uh, variety. But it's
Verisimilitude.
yeah. Well, that's veracity. But take inventory. Where is it? What is
Yeah.
it? And how confident are you in your data? And everyone thinks they know where it is, but I've yet to find anybody who does. So when we finally do that actual inventory and map everything, it's always a surprise to the organization. And you can't do meaningful, whether it's, business intelligence applications, digital twins, much less machine learning and AI within your organization until you do that inventory. And that is, where is everything? Where are your experts in on what topics? Those sorts of things. Mapping that is a critical first step. The other really critical step is avoiding what we call now AI contagion. And that's, as you're organizing data and performing functions on it, now we're performing functions with machine learning systems. We used to do it with the old AI, just business rules, business logic. Now we're putting them into black boxes and it outputs something and then that new AI mediated data comes back into the organization as a contagion potentially. All right. So what you'll hear about today is we've introduced something we call the epistemic airlock. And that's a place that grabs anything that's AI mediated and requires either a human or a very well designed AI agent to validate and verify that data and take responsibility for it before it comes back into the organizational knowledge repository. And the issue with that is if you don't do that early on and you took the move fast and break things approach to implementing AI, whether it's generative AI or even the old symbolic stuff, you risk having that contagion. And once you're infected, it's kind of hard to exercise it. And so we've designed a system that we'll talk about today that is an approach and a methodology to avoid that.
Yeah, that's great. And right behind you, you have the book that you is actually a sub. It's a repository for these meetings that you've had, gatherings of people called Simulation Century for, I don't know, what is it, 12 years now or more?
Yeah, this is the 15th year that I'll be
15th
doing the
year.
Simulation Century event at Mod SimWorld, which, by the way, is, and I'll have a little thumbnail about this. It's next week in Alexandria, Virginia, where I'll be talking about the new scientific method, which is something which is also related to veracity of data. And as we know, there's a big issue about well, I'm trying to be politically correct here and say that there are some efforts to try to rewrite previous history
Mhm.
or get rid of data that someone doesn't agree with, and we don't want that either. We want to be able to preserve dissent, and I'll talk about that today and show you exactly how we do that. But you're not allowed to go back and erase like a temperature reading on a buoy from 1982, which, by the way, are things that are actually happening right now that we all need to
Yeah.
be aware of.
Well, yeah, I think that having a body of knowledge that's trustworthy, right, is, if you're depending on these systems to help you with decision making, you want to be able to trust, the data that's inside the system.
Yeah, I mean
Mike,
that's the core issue. I think is how did information enter we like I said, if you take the the thesis that we are in an information age, and acting on information is incredibly important. That's the new data is the new oil. All those things we've heard for quite a while now. It's important to understand how did information enter your organization, whether you're in the intelligence community or you're doing business intelligence in your IBM or GE or whoever. How did it enter your organization? Who championed it? Who challenged it? How that got combined with other bits of data, along with expert analysis to turn into some kind of course of action. Why did we choose that vendor over that vendor to
Hmm.
have as a product we sell in our hardware store? Talking about someone like Lowe's or Home Depot. I mean, these are real examples. Or, we heard that there are weapons of mass destruction in this country. Who originated that idea? Where's that original data? How did that get corroborated, validated, verified? And how did that turn into a course of action that resulted in $1 trillion of spend and lives lost? That's critically important. Those are big, swings in terms of importance as examples, but it's still critically important in an information age to know like what can you trust, and when you start having AI mediate your data, the risk is now exacerbated. So,
100,
a couple little
100%.
tools we can implement um, to actually combat that, and that's what I'll show you live here if you want to dig in.
Yeah, in just a second. One of the characteristics and, prime reasons that you were invited is we all know when ChatGPT hit the ground running, and we all started to think about this, but you've been at this a lot longer. And one of the things that's interesting about this is all of this has been, suck in all the information that you possibly can, into one place. And what I find interesting about the approach that Richard's team is taking is that, no, leave the data where it is, right? And then you can federate it, right, in ways. If you want to put it in one data lake, you can, but you don't necessarily have to. And so that's part of the discussion. I think that's net new in, you're beginning to hear people talk about that, like David Bray and Richard, but I think that's a new component of it. What do you think, Mike?
Well, I mean, yeah, this idea there again that you don't have to re-architect all your storage systems and aggregate all in one place, not new. However, I was still surprised that Richard is saying his example with the 70 deployments that none of them had the 4 Vs in place. I, I, I mean, honestly,
They thought they did. They were
I'm
wrong.
an old guy, and for 22 years at working with digital marketers at the dawn of digital marketing, that was one of the things we kept saying. Is like, you got to go through, you got to not centralize, but you have to organize your data. You have to understand what's active, what's
Mm-hmm.
old, what's doubtful. And I'm just surprised that that must have been the 70 companies that installations that didn't talk to me
I mean,
back 22 years ago. I'm finding that amazing that they still haven't. Okay,
yeah,
at
this
least
is
have they structured their data at least at this point? Do you find?
always attempts at structuring, but because the everybody's got big data now, it's beyond our capacity to the human capacity to sort of monitor. We need tools, and that's true of so many things in the information age, is it's insufficient to be standalone human beings or even collections of human beings trying to perform these actions because the complexity is beyond our, my joke that my standing joke that you guys have already heard is, we humans haven't had an upgrade since the Pleistocene. And so these machines and these things that we're implementing are exponentially increasing in power,
Right.
and we haven't an upgrade in a long time. But the example, and I won't say the name of the company, but a major research institute with thousands of researchers, and it started. And we built a big knowledge graph with them, and actually had Sam Adams, the guy who came up with the 4 V's at IBM, working with us at the time, and said, "Yeah, we need to get this under control. We need a knowledge graph before we can even do any kind of machine learning application." And so they had all these different research institutes. And I think it's important that, number one, a rule I have just in general in life is no unnatural acts. And it is very often an unnatural act to try to combine everything together. There's a very good reason why some of the data for the healthcare researcher doing and PHI information and studies is behind its own lock and key. And when I worked at Lockheed Martin, we didn't call them silos, we called them cylinders of excellence, but they all have their security classifications and just a variety of reasons why data is stored behind locked places. What that does, though, is initially it breaks enterprise search. The minute you try to search across that, well, you can't see into those locked doors. So you've got these dark pools, these dark data lakes all throughout the organization. And you can't, it's unnatural to say, well, copy all that and put it into one big place.
Right.
That never works. It's not the way people work. So you have to accommodate the way people do information work by necessity. So what we did is we built these little connectors that have their own individual agent permissions to go into those places, map all the metadata on it, and I'll go through the actual methodology with you. But once it's mapped, you're bringing over to the other side of that wall just the metadata, and you're searching that. So that lets me do things like, say, I'll start working on a project. Let's say I'm working in that research institute on smoking cessation. I start working on it, and immediately it says, hey, there's a lot of high value assets around the organization. Some of them are people and experts you're not aware of, and some of them are information objects like studies, videos, different kinds of artifacts. Some of them, though, have a score of 99 in terms of how relevant they are for you, but you don't have access to it. You're going to have to go talk to Kevin or Mike to go get access to it. But I can tell you that these assets are there. It's like a really good research assistant. I used to describe it as radar from MASH, but people I talk to today don't know what that means. But radar would even anticipate what Colonel Potter needed and bring it to his attention, and that's the kind of thing that you really want. But in this research institute case, they said, we have a 60-year, really amazing history defined by our 80,000 peer-reviewed scientific research articles that we produce. And so there's no doubt they produced all that stuff. And it was stored in all those little dark pools, or sometimes just on a human's hard drive. And when that researcher left, they took it with them. So we revealed right away that, we said, what did you think you had as an inventory? Here's what we found. And it was a very small subsection of that. And everyone was furious. But the CIO at the time ended up writing us a letter saying that first step you took of inventory revealed that we have a data storage, retention, and retrieval problem, that we need to address that. And that's, first. Or we are leaking organizational knowledge. And they didn't even know it until we did that inventory.
So I think that's a great place to start to actually show some of the things that you're doing, Richard. So let me put us into that configuration. And here comes the
Configured
chart. Here, thank
the
you.
horizontal and the vertical.
Yep,
Yep.
here we go.
Right. So hopefully you're seeing this thing that says new scientific method. And I added just before we started talking AI contagion and epistemic airlock, because that's what we're going to talk about. And you'll notice that there's a little sticker on here. It says RJB verified, verified and approved, true and accurate. And this is me putting my imprimatur on this thing. That means that there's some of the stuff in here that is AI generated. And anytime you see one of these, it's that I used AI to mediate my content, but at the end of it, I put that stamp on it. And everybody in my company has one of these stamps. So we don't let anything come back in unless a human has taken responsibility for the output. And that's just one of the pieces we'll talk about. Here's the event next week for any of you who are in the DC area. Please come by. But here's what we were just talking about, and I'll just jump down to this. Like I said, everybody has big data. And that inventory step is we used to just say that's the, we're burying the lead in especially assuming that everybody had this under control. And we found, like I said, after 70 some deployments that nobody does. So the way to do it is to make those connectors, use the architecture, which we have refined over time. And you'll hear us call this the data fusion plane. And by the way, the data fusion plane is not an original invention of ours. It's we looked around like everyone should be doing today and said, how do we stand on the shoulders of giants? Who's already created who's already tried to solve this problem, or is it a solved problem? And it turns out that DARPA was trying to solve it before, and they created this thing called the global data plane, which is just how do you take lots of disparate data types and create what they called the narrow waste of data. And the really cool idea there is like when you go to a web page on the internet, you don't have to know what kind of data types are on this page. I gotta make sure I have all the plugins, and I gotta have something that can read a spreadsheet and something that can read tabular data and something that can watch a video. And you don't have to worry about that. There are standards, and there's one place you go and you can see all that data. And so how do you apply it to everything else? And that was kind of the DARPA global data plane effort. Then there's another effort that was at Berkeley called TerraSwarm, and that's looking at Internet of Things, just volume, right? If you have lots and lots of sensor data and drone data and all sorts of things, how do you manage that as a human who hasn't had an upgrade since the Pleistocene? And so what we've done is we've taken those two things, combined it together into this architecture, and a methodology we use, which I've just roughly described, and I'll do a little bit more here about how do we wrangle all that data into one place so that any organization can now do those higher level functions where you can go from here to information. And everybody's here, but not enough people have made it here. When you get to information with a capital I, that's where all your data is, you know what kind of data it is, it's normalized, and it's, in the case of machine learning and things today, we have it embedded, vectorized, it's got meta tags on it. It is what I call transparent to inquiry. And until you get here, you can't do this stuff. The biggest problem I see is people we have lots of data. Let me bring an LLM in and slap it on top of it, move fast and break things. And they do break things a lot because you end up with all kinds of problems. So you got to take this step. And then the last step is now where we're going to spend some time talking about epistemic airlocks and whether you use how do you maintain data sovereignty after this so you're not giving up this high value structured information you've created. If you start uploading that into Anthropic's stuff or Grok or anything else, ChatGPT, you're now giving them they're going to train on your data, even though they promise not to. I'm convinced they still do. So how do you keep this all internal? And that's what we'll talk about today. So a little bit of history that Kevin talked about. I know some of you've heard about my first machine learning project was 2009, Microsoft Connect at Microsoft Research Labs. But shortly after that, the Arnie Duncan at the Department of Education came over to us and said, we want to do digital transformation of all the data in the Library of Congress and the Smithsonian. So they had human experts looking through everything and tagging it, and so that it could be transparent inquiry, trying to make this step from here to here. I was at Lockheed at the time. We built this thing called the Learning Registry. Was first we had to make a knowledge graph. If you guys remember knowledge graphs, and we had to come up with an ontology. Raise your hand if you know what I'm talking about when I say ontologies. Who's worked with OWL and all these old tools that we had back at the, way back then? Uh, and our initial ontology for all human knowledge ended up just being the Dewey Decimal System. So there were 999 topic vectors or topics that we mapped all information in. But then that expanded, and here's what we did with my first machine learning company, Tanjo. We let the system decide for itself how many meta tags need to be on a piece of data. So if I read, if I'm talking about War and Peace, it would say like, a human being might say that's Tolstoy, it's about war, it's a love story, it's a really long novel, it's Russian. I would probably stop and say someone can probably find this now because of those meta tags I put on it. But we would put up to 4,000 tags with everything that's pertinent or relevant embedded within that really massive thing. And that just, because we had this extra power of machine learning and we had this extra power of storage and compute, I could do it. And it just makes it makes it much, much easier for the machines to now do those higher level functions on it. So today it can be way above that, but we usually stop then. I'll get back to this in a minute. But the other thing that's really interesting, let me talk about knowledge graphs for a second. So this is a war game thing that I was in. I'm just doing this to show you this guy, Doug Lennett. So early in the machine learning wars, in the 90s and all the way up until 2023, the war was sort of between like, should we try to do symbolic AI, and that's what Doug was doing, my friend there, who really that's where I got religion on knowledge graphs. He's like, if you can really bound the context and describe something, and he had this project called Psych, where he was trying to describe reality with 100 million sort of declarative statements. That's one approach. But if you can do that and you're confident every one of those declarative statements is true, it really does help with avoiding any kind of errors or incorrect data or that kind of thing, assuming all those are true. But that was a gargantuan effort. And a lot of people just said we don't need to do that. We have this generative AI capability where we can interpret reality and create something better. But I still believe, a big piece of everything we do is create, what is your unique knowledge graph? What does it look like? And if you bound that context and do things on top of it, you get more powerful applications. So we started doing knowledge graphs. Like we would, when I was at some conference and somebody said, it was like one of these Y Combinator like things. And they said, you'd be worth $1 billion if you can just make an AI system to do law, that AI lawyers. So we went out and found every single legal opinion in US history, right? It's over about 4 million legal opinions, really large documents. And we used something called LangChain and TextRunner, if you guys remember that stuff back then in 2014, built this massive knowledge graph that we can then start building the context around law. And that's what we would do, is build these big knowledge graphs. The other thing we found really interesting, and we started talking about the new scientific method then, is that you could then have these machine learning like agents look at that massive set of data and just come up with hypotheses. So an automatic hypothesis generator. And this is where I first started talking about the new scientific method. Now, a lot of the stuff, you see these X's, it would generate a lot of stuff and you'd look at it and go, that's insane. That's crazy. Don't do that. I'm not interested in that. But then very often, and in fact, in almost every case, you would find some sort of new novel insight that would occur to machine intelligence that never occurred to any human expert, because we kind of get locked in our little lanes. So this was a powerful capability, and it's also called NORA. You may have heard the term non-obvious relationship analysis. That's one of the things machines are really good at, is looking at massive sets of data and coming up with that. But again, this is where we said, first, let's get everything organized. Let's use this thing called the Data Fusion Plane. I'm going to show you in a minute how thing that we've done for NASA, where we took 270, I keep having to update this number here, 270 petabytes of data in all these data archive centers, which again, were in these silos all over the place. We've combined that together using the data fusion plane into one transparent to inquiry sort of database that allows us to see correlations we could never see before. And it's resulting in new insights. It's extraordinarily exciting. And that's what we'll be talking about at the Simulation Century event next week in Arlington with some folks from NASA's Goddard Research Center and from NOAA about a lot of this Earth data. So notice again, this image was generated by AI, so I had to make sure that it's all accurate. I'm taking responsibility for it. I've got my little tag on it. And some of these things don't have tags because they were human made by me. Okay? So I'm already taking responsibility for it. But these are the steps. So the data fusion plane is just that necessary thing of connecting to stuff, making sure that I have a full inventory of everything, and it's in a place and in a tagged and embedded mode where now I can perform AI on it. The next step is what we call sovereign intelligence. This is where data sovereignty takes place. And in here, it's about looking at the kinds of functions I want to do and deciding, can I get by with a local LLM? And then I'm going to jump down here and say the other key is making sure, and this is what we believe strongly, whenever possible, I want to do Doug Linnett's thing and express it as something that is a declarative if then else, the old AI, if you want to call it that. Where I can say, I know this is true. I want to take all my knowledge and express it that way. And we only use connectionist or interpretive generative AI when it's really going to add a lot of value, when it's necessary, you could even say in some cases. And this hybrid capability is a big part of the kinds of systems that we deploy. But these, again, are the levels of it. You've got data fusion plane, connect all the data. Veritage, I'm going to talk about here next. And then you have this ability to look and be transparent about where are all those data sources, how does that data enter the organization, and what functions are actually happening on it. And this transparency, I think, is really important. And then finally, being able to verify the chain of custody all the way back to where did that data come from, who modified it, did AI ever touch it? And if it did a human take responsibility for it? These things are critical. And this is part of this presentation I'm showing you is part of what I showed to the CDAO. This is the Chief Digital AI Office for the Department of War now. But we're hoping that this will get all this across to them so they'll start implementing it. But they're showing a high level of interest, which I think is positive. All right, so let's talk about AI Contagion just for a second. I've already described this a couple of times, so I think you guys get it that, a human can create something, or sometimes even AI creates something. And if it doesn't get validated and verified, which we do in all other, like I come from the simulation industry, and in that field, let's say we spend about $14 billion a year on just simulation in the military. A big chunk of that is doing what's called validation and verification, V&V, on the sources of data to make sure you get good ground truth. And if you don't spend that effort, you get bad outcomes all the time. And avoiding that in AI implementation it's obvious to all of us from that industry, just mapping it over. But people are running and gunning and just slapping LLMs on top of data, and they don't understand why, they're getting, bad results. And this is why. So the way we fix this is what I call the epistemic airlock. And that is a place in the topology of the system we build where we say, hey, AI has touched that, or some human used AI. That's an AI artifact. And you saw yesterday, I believe, Claude is now saying they're putting watermarks on anything that Claude generated. I think that's good. I mean, there were already some in images and other things, and And I know people can override that pretty easily. All you got to do is copy it into a text editor and you can pull out that watermark text.
Mhm.
But if you require that in your organization, if you're the CIO of an organization, if you're C-level, you should require that this epistemic airlock is here, those watermarks are there, so you keep track of anything that may be prone to hallucination or just errors, right? And that we require that humans take responsibility for the data that's output. We can also do this at the sub level. So if I take a large document, I can have people, like let's say you take a bunch of smaller pieces, put that into a larger document. We can put meta tags and track the sub data that goes into a larger thing, and even be able to see, for example, that one or two people in the organization actually challenged or disagreed with something that's in a document, and that gets preserved. Now it can be overridden and said, well, we're going with it anyway, or we're approving this anyway. But that the fact that that person challenged it, and I think this is part of the scientific approach, the willingness to be disproved, the willingness to record and preserve dissent is really important. It's important in the intelligence community. I think it's important in business, and certainly in science. So that's why I'm mapping it across all this. I hope this is making sense to you guys.
Yep.
But let me just show you. In fact, I'll go to a. Let me go. Well, I'll just show you. We're doing this in a wide variety of industries. So this is mapping satellite information and ground station information. This is the one I'm going to show you in a second, with all of the NASA data from all over the world, and for weather data, 170 different weather stations and what's happening there, war games, hospitals. So we're deploying this there, and again, tracking and verifying data that's happening across these really complex environments is really critical, or big war games. But this is what I'm going to show you next, if I can pull up one of these. So this is, let me go here first. It's going to make me go back in. Well, we have to make sure we validate everybody. So this is an entire system, right? So we like 3D stuff, but you can look at it in 2D as well. But in this example, when I'm using an intelligence example, it's really important to say someone's brought information in. And since I'm back here looking at the entire system, hopefully you guys are seeing this, I can see this is the entirety of the thing that I'm doing to process my information in this organization. So I can look and see who brought that information in, where did it come from, and as it's processed, what systems does it touch? Where is it stored along the way? What applications? And this is a live thing. So I can actually go here and see that, it's happening. The MCP, the agent-based LLMs are processing it in this AI foundry. Or did it ever get touched? And so far, it hasn't been touched there. It's just been uploaded. But where does it go? And then what functions are performed on it? And when I click on any one of these, this isn't a abstraction like a architecture graph somebody might create for a system. This is a live thing connected to the actual system. So there's a couple of benefits to this. One is I can see where information flows are, what people do with information. But when I have to go for SOC 2 compliance or authority to operate on government networks, things like that, this really, some of the metrics we have now, it reduces the amount of time it takes to get those audit certifications by about 40%. Because anytime you're doing an audit, what you're looking for is transparency. And this, I can answer any questions. If my system's doing a comparison query, it can do this, and I can see where the information is flowing and exactly what's happening. In the example of, I'm going to go to this Earth data one. This is the knowledge graph for this. Here's all the sources of information, how much data is in each one. I can go click on each one and get information about each one. But then I can see, and it's kind of buried in here, but this provenance ledger, this ledger with all these actions that are taken over here, that's the thing that's meta tagging every piece of data that is brought through this system for NASA. So NASA calls them granules, but an example of a granule would be, like I said, a temperature reading on a buoy on a certain date, so, with this geographic location. That is a granule. That gets combined with other data and then turns into scientific research. But what we're doing is we're tracking that entire provenance. So it is a blockchain like, a ledger like capability where we're just, it's write once, read only, preserves any dissent, and the whole provenance of that goes all the way through. So we keep ourselves honest. And also it means that it's indelible. It can never be, I mean, people can go and delete all these databases, I assume, but once it gets to a certain level, it's kind of hard, just like, with any kind of ledger-based system, it's hard for any one individual to go through and try to, because there's copies of the ledger all over the place. So we think this is critical for preserving trust and truth about data in scientific research, but it's equally true for information about what's going on in your organization. So here you're about to see this is 270 petabytes of information live in a web browser without a net, except the internet. But I'm looking at land surface data. Notice it's hierarchically collected in these higher level things. But if I go here to land surface data and I click on this, and it's going to take a second, but I'm going to start loading, and it'll end up being like terabytes of data at this level. But I can go in here and start asking questions about things, or look at the location or source of all this information. And as I click on any of these, I'll start drilling down, kind of fractally into all the data that's available from all 270 petabytes of this information. And now what I can start doing is creating, I'm not going to try to do this live in front of you, but scientific researchers, and they have over 10 million subscribed to this system, will be able to come in here, generate a new lens and say, look, I want the agents in this system to try to come up with any hypotheses that they can come up with around anything that might be contributing to El Nino. So if I've been studying El Nino before, maybe I'm only looking at the water temperature data or weather effects. But what if I started looking at all the data that's available from all this earth science? Might I find new insights that didn't occur to me because I've been in my silo for my cylinder of excellence studying my data, and it never occurred to me that bird migration patterns in the biosphere or some of these other things might be other correlations that don't occur to experts, that the machine learning system, because it has no preconceived bias, might find. It's really exciting. So we have some folks actually at Goddard today looking at this. And just jumping back to this, I mean, anytime you're looking at any size of data, we're looking at here, I'm tracking all 10,000 Starlink satellites at once in a web browser, connected to their data and looking at how the ground stations are talking to them. It's an extraordinary new way to look at information.
Richard, this is outstanding. Ready for some questions from the folks who are participating?
You bet.
All right. Ben, you've been, as usual, contributing mightily in chat. Why don't you jump in and join us?
Excellent, excellent interchange, and very much appreciate, Richard, your comments. When one of the first things I think about is that we've historic mistakes over our 80 plus hundreds of years in dealing with data, as we treat data as passive, as a singular artifact. If I think about your buoy issue, I often look on the data as a very slow process. And so that the record of the temperature of that buoy is an active process. It just is episodically recorded. And and does that change if we start moving away from thinking everything about data is dealing with the with passive artifact, and that these are active flows? Now they're going to have to be richly recorded according to your models, but no, but nonetheless, that they're not just static things that we're connecting to interpret. They are things that could be living artifacts themselves.
No, I think that's a big component, and a lot of these higher level questions, like the ones you're asking, don't even occur to most people until they get to that. They make that first leap into information where they've organized and tagged it all. Then you can start asking these higher level questions, and I think that's what's exciting about this. But our data scientists are always looking at the many V's of the data, but also looking at, is it data at rest or data in motion? That's an important thing. Another big consideration around those connectors I talked about is like, what are they connecting to? And, Kevin, I'm reminded of what we did for the state of Washington during COVID, where we had, I recall, 188 different data sources we were pulling every day. Some of it was weather information, which if I wanted to, I could decide to pull every minute, every second, how often temporally is reasonable. And I want to talk about temporal in just a second, but some of the stuff is data at rest, which is, this hospital has this many beds available, and that never, or capacity is this. Then the data in motion is how many are actually being used right now. And I can look at, we were looking at movement data about humans, we're looking at weather, we're looking at traffic, looking at obviously infection rates and things like that. But all of that gets pulled into a higher level model where it says like King County, state of Washington is an 85% chance that it can actually reopen and be fine. And why is King County 85 and the next county over is a 60? And the people over there are angry because they're watching kids going back to school over here and all that. But this is something I've been very passionate about, and I write about in my book that, the book Competing on Analytics came out, I think, 2009. And we should all be talking about data. And we should always have data infused discussions, not or data supported discussions. It shouldn't be about gut instinct or what people's feelings are, any of that stuff. And I felt for all these leaders who are trying to answer questions about policy when they should be saying, when we made the decision to do that, here's the data that was available, which you can question. And I think that's fair. And that's what this is about. What's the real provenance of that data? Is it accurate? Was it trustworthy at the time? Is it temporally correct? Like, when was the last reading? Oh, it was 2 weeks ago. It's like, well, that's not really relevant anymore. We need a more recent reading. And then you can question the models, just like in weather forecasting. There's 8 different models trying to predict that hurricane path, and that's a completely relevant discussion. But that's the real conversation we should be having: data relevance, how temporal is it, and then what models we're using to do functions on it. That's the real question.
Yeah.
And
And
that's
the other thing that I would just add, Richard, is that we were comparing data sets that normally didn't coexist. We had health indicators along with economic indicators, along with quality of life indicators, living in the same space so that you could see the interaction between all of those that would sum as a decision set. Go ahead, Ben.
And let me just add this real quick, Ben, but that the other temporal element of this, which is most exciting, is you're right. Like in most cases, we're looking at the past. This happened in the past, or maybe I'm looking at readings that I'm taking in weather like right now, but it's still sort of in the past, like seconds ago. But now we have the ability to look into the future and say, what if? What if I change some of those values and I change some of those data pieces? What if this happens or that happens? And we're doing this a lot in the healthcare industry, certainly with hospitals. Like, what is your capacity? Like, everything's flowing fine now, but what if you have a pandemic? What if you have a surge event, like a mass casualty event in your area? How are you equipped to do it? And what would you do? Or what could you do if you detect that those things are happening? When you have something modeled at this level that I'm showing you here, now all of a sudden you can go into the future. And what I say is not just predict it, but design it.
That's important. That blends the issue of context and of a theme I used to write about on data immortality. That looking at the ephemeral nature, especially for the future, if it's speculative or projection, then it may not be important to be immortal. And we can't perceive that all data is needs to be immortal, and contextually we've got to apply relevance filters on this so we aren't overwhelmed either, because I'm assuming everything you're a part of your judgment is relevance for today and relevance for tomorrow.
Yeah,
Mhm.
exactly right. So I'm going to add Felix Nader in now. Felix, welcome. You had some thoughts about regulation. What should Congress and or the executive branch be doing in this space? And I'm going to, before you open your mouth, I'm going to say, Bob Pulver wants to know where he can get an Ultisim T-shirt because he likes your logo. So
We've got some
maybe you
gear.
can collect his
I
address.
can definitely help with that.
Okay,
There's
very
Linda
good.
Bernard. Yes, we have the pins, and we like to say because we're gamers, we said the pins. Every pin adds 10 IQ points. They don't stack though. If you're a gamer, you just can only do one. And then we have
You
these
could use them as
patches.
epaulets.
We have these patches that are, maybe I have it backward. The patches improve closing rate by 10
All right.
10% on it for our salespeople. So they try to put a lot of patches on there.
All right, over to you, Felix. Your question.
No, I was just curious. By the way, Richard, this is outstanding. I was just making some notes because for years, I've been consulting privately using my ability to understand the nature of my work to help my clients how to be proactive rather than being reactive. What you just said is so formidable because if we can convince the C-suite today of the predicticality of what they're failing to recognize, we can get credibility and trust in those recommendations that we make.
Yes,
Incredible.
I'd love that. Exactly. And one thing we're really big on that you see, and hopefully you saw in some of the things I showed there, is too very often, whether it's in mission needs analysis for the Air Force, or it's uh, pandemic response, or it's responding to a mass casualty event like a hurricane or something like that. You have people creating these like charts and graphs, and they're in front of people, peppering them with questions, and they're answering the questions, and they're looking at the charts that were prepared, and they go, "Oh yeah, that's a really good question. Didn't occur to us. We'll go back and let the analysts go study that." And you know, one of the reasons Lockheed bought my last company is we built a thing that could answer really complex questions like that in real time because it's connected live to the data, and all the
Exactly.
things that we have here are connected to data where if someone asks a question, I can go, excellent question. And I can go look at it and say, well, here's the data, here are the models. If I change the value of that model, I get a different, what you just asked me, I get a different result. Or, in the military, there's these things called compliance rules, .mlpf. There's like tens of thousands of these, like, can you do this or not? And just because I can afford to give somebody a radio in the field doesn't mean that they're trained to do it, that they have the right doctrine, that they, whatever, it can be supported, all that stuff. And I can instantly, something that used to take 300 hours of human analysis, because it's connected to the live data, I can point to the business rule and or the physics constraint or the telemetry constraint that prevents me or allows me to do the thing that you're asking me about because it's connected to the data. And that is a superpower that I think every C-suite person should have, but they can't do it until they get the data in this form.
Exactly. Thank you very much, Richard. Thank you.
right.
That's a great question.
Suzanne, come on in. You had some comments, and I'm sure you liked what you were seeing for NASA data, didn't you?
Yes, I did. Richard, this was outstanding. Um, I'm blown away. I wish we could have an extra hour because I'm contributing to a book for the desirable properties for the next web. and hear all of your research, all of your work with your company is contributable with the one I'm working on, which is number 15, and which is providence and and sovereignty, and this is so important. Do you think that maybe this could potentially be not only a desirable property, all of your work, right, as a desirable property for the next web, and don't you think it could be the governance layer for an additional V as well? I mean, I know in biodefense and in space biology, the data sets are extremely sensitive, and it isn't because we have so much data and so much volume of that data. We have complete access to so much data, but there needs to be a human in the loop to assess whether that data is valid. So I'd love your input. If you think it should become.
I think we should absolutely sidebar on this. And one of our I know our colleagues, David and I have talked quite a bit about this whole subject of what can you trust in this like spinning, uh, just out of control system. We built systems so complex humans can't fully understand them, and yet we hope to control them. And we don't know what's real and what isn't. Like, is that video real? Is that a real human contacting me right now? Is the information being supplied to me real or not? And how do I detect that? And I think some of the things that we're talking about here, like I didn't go into too much detail, but the thing we built under, for NASA, which we're so excited about, we're doing the same thing for NOAA, is there are agents involved. And because I said sometimes it's just like it gets too slow for humans to have to validate everything. So
Right.
creating agents that you can really trust. And I use the example from my Lockheed days of when you have an autopilot, there's never just one AI autopilot. When the guy flying your 747 from LA to New York puts on the autopilot, it isn't just one AI. There's usually three. And anytime that a course correction because of weather or whatever starts to happen, unless all three of them agree, they have to call. If they don't agree, they have to call the human to intervene and override and call like the ball. But you can also have, and with the NASA thing that we have the generator, the critic, and the judge, and these are AI systems, but they're highly symbolic. So remember my hybrid thing there. It's not a generative AI thing that's dreaming stuff up. It's got some hard business rules, and some of them have certain rules that are weighted more than others about safety or about, in this case, about integrity of data or source or whatever. But they can adjudicate something pretty quickly and say the confidence level of this is 98%, so I don't need to bother a human. But if it's below a threshold, and we use this even on that learning registry example I did, if I had my automated tagging system read War and Peace, but its confidence level about whether it got it right was below 70%, it would say, I got to have a human come in here. I need a human expert. But that frees humans up to only spend time on those things that are not just very clearly verified by these very trustworthy agents. And we have to constantly look to make sure those agents are trustworthy. But there is an architecture there that obviously this is a deeper conversation we need to have, and maybe have David on there too. But the
Yes.
ledger, the one thing that blockchain really got right that we've used in computer gaming, which is also my background, for verifying whether something's authentic is just the hashtag capability that's read once. I mean, I'm sorry, write, read only, where you can never change the chain, and that it's distributed, meaning that lots of people have copies of it. That's how you maintain authenticity, and that's important in all this stuff that we're doing.
Yeah, absolutely. I'm so excited. I completed a proposal, and I see where PCI, you, me, and NASA with an early warning system autonomously, an early warning system that I have designed that fits into everything here. So we have to have a meeting again.
Let's sidebar for sure. Absolutely.
My heart's pounding because this is so relevant.
Good. Excellent.
Awesome. Okay, cool.
That was a desired effect.
Thank
Yeah.
you, Suzanne. That's great. Outstanding.
Okay.
Yeah, Richard, I remember the ascent and descent computers for the space shuttle program had 4 IBM systems and 1 Rockwell computer. And they all had to agree, and they were the Rockwell computers and the IBM were programmed differently, right? So that you would have a comparison of favorability for launch or coming back into the atmosphere. And it was exquisitely complicated, but these were very small computers compared to what we use right now. You know, they were probably
We're all using A-star, and by the way,
8-bit.
we still use A-star today.
Yeah,
That old like symbolic AI pathfinding system.
yeah, 100%. Mike, we're coming up to the top of the hour. This covers a lot of territory in terms of when you think about Santa Fe Institute thinking, which is you have a worldview, all right, that's your data, and then there's a fitness landscape. The fitness landscape, right, can be changing, and you need to be able to do the compare and contrast between what do I know and what's happening in the world around me. What Richard's describing is intersectionally, having, ground truth for both. And that's really interesting because, this isn't either or, it's a both and. What are you getting out of this, and where would you point him next in terms of, how useful this might be, all right, on
I
in
wouldn't
places
steer him.
we haven't thought about? Because I keep on thinking of other places this would be useful.
Well, I wouldn't steer him away from NASA. I would say, you might want to follow up on that. NASA would be a good place to start or to continue this. But
Your
what
gain is
got,
low, right? For some reason, lean in, my friend.
yeah,
There you go.
Richard, what struck me was, as you've been speaking, and granted, I was seeing from the early days of Tanjo when I was still at that one research company. The thing that's always been missing that I've seen, which I've gotten hints at, because I attend to work with a group that Suzanne's also a working group called On the Meta Layers, is that thing the phrase you used earlier on, which was these systems now are getting so complex, they give us insights and answers that, frankly, we're not capable of understanding, right? And what always struck me was the thing I went through the deck, it was you're providing now internal and external consistency, or an ability to create internal and external consistencies, right? Which we all remember from our 7th grade English. Does the story hold together itself, and does it map to the world that we know, right?
Internally consistent.
Internally and externally consistent. And this seems to be the tool that I would have as an entity or a business to ensure that my data sets are both in that kind of fitting. Obviously, you're doing much more complex stuff, but it seems to me that if we're going to be trusting any of these systems, or more importantly, industry groups put a label called trusted on some tool or output, you've conquered what seems to be the initial problem. Does this thing, is it internally consistent and externally consistent? So thank you for that.
Just because a human puts that stamp on it doesn't mean that it's true and accurate. It just means a human's taking responsibility. And I want to point that out, right? Because 100% veracity is very often not possible. And it's certainly not possible. We're doing some war game type stuff, and you never have 100%, veracity. You can't verify 100% of everything. You got to deal with some fog of war. And but at least you can see with the data you had a confidence level of 78%, and you're going forward anyway. But someone's made that call, and that's, at least you've got that clarity instead of saying we didn't really know at all, we just guessed.
Yeah, yeah.
Or didn't look, or worse, didn't look.
Yeah.
Yeah, we used to have something before we released something to the marketplace called reliability, availability, and serviceability, RAS. Okay, and in a way, what you've created here is a RAS system for for data as opposed to a machine. Can I is it reliable? Can I trust what's in there in the system? Is it available in a way that I can actually understand it's not degrading? And can I go in and tweak it if I need to, e.g. serviceability? So it's great stuff. Richard, you have the last word. What would you like people to remember from our time together today?
Well, I think the thing I didn't really mention too much about is whenever and wherever possible, all the components of that big system those big systems I was showing you, we try to use open source components, things that are readily available whenever possible. So that I want to use Postgres, SQL whenever possible as a database, not have a database that has a third party who encrypts that my own data for me, which happens with companies like Palantir and a bunch of others, right? So avoid that whenever possible. Maintain sovereignty of your own data, and so that's incredibly important to us. The more open and transparent it is, the more you have control over your own data and what the outputs are. And I think that's important. But that operational view at the end, whether it's a hospital or like the hospital folks we're talking about, the superpower we're giving them they've never had before is every single department in the hospital or across the hospitals that an organization has, they can go back and play back any given shift and see what happened in that emergency department at that time. What was the data? Who were the patients? What were the staff? What procedures were performed? When was there a choke point or a problem or whatever, and then how do they avoid that in the future? And then they can interrogate all those flows with AI. But imagine having a bunch of these screens all around you in the boardroom looking at the actual and having actual drill down to real data as opposed to here's a report that I have to read, which is still the standard.
Yeah.
Yeah. Well, thank you for joining us today. You seem that you had a lot of enthusiastic response, right, to what you're doing. Keep going, my friend, right? And in everything you do, be intentional, folks. We'll be back next week when we'll be talking about these new special purpose vehicles, right, as a financial mechanism funding data centers and other things, right, that are appearing in the economy. So take care, and we'll see you next week. Cheers.
Thanks, everybody.
Thank you. It was awesome.